Welcome to the Deep Dive. We take your sources, pull out the key nuggets, and basically give you a shortcut to getting really well informed. Today, we're embarking on quite a fascinating journey into GNU Linux commands, specifically what it takes to really master them for the Red Hat Certified System Administrator cert, the RHCSA. Our source today, it's like this meticulously crafted treasure map, a complete roadmap, really. It summarizes all the commands an RHCSA needs, grouped by the actual exam objectives. It's designed to show you exactly what Red Hat expects, and maybe more importantly, how you'd apply it in the real world.
Yeah, and what's really captivating here, I think, is that it's not just a checklist, not just commands to memorize. It paints this whole landscape of practical skills, from the absolute everyday basics right up to some pretty advanced techniques that, frankly, separate someone who just uses Linux from a real administrator. So our mission, if you like, in this deep dive is to guide you through this treasure map. We want to reveal not just what commands matter, but why they matter, how they connect, and really where you should focus your energy to get that solid, hands-on expertise.
Okay, let's unpack this map then. Where do we start? The source talks about a daily toolkit. These sound like the absolute fundamentals, the things you're typing constantly.
They really are.
Yeah.
Genuinely the building blocks for interacting with any Linux system. Think of it as your essential vocabulary.
Yeah.
First up, file and directory management. Commands like ls to list contents. But, it's more than just ls. Understanding flags is key. ls-l for details, permissions.
Right, the long listing.
Exactly.
Yeah.
Or LD to see hidden files, crucial for quick diagnostics. Then you've got EDB for copy, MV for moving or renaming, RM for removing files.
Right.
And please always use RMM for that confirmation prompt unless you are absolutely sure.
Good tip.
Yeah. MMedior makes directories. RMDiR removes empty ones. LN creates links hard or symbolic. Very useful for organizing without duplicating data. And touch. It doesn't just make empty files, it updates timestamps. Key for scripting sometimes. Finally, find your system detective.
Yeah.
Locating files by name, type, size, modification time. It's way more powerful than just locate.
Okay, so those are the tools for moving around, organizing things. But what about actually looking inside files or, manipulating text? That feels like where the command line really comes alive.
Oh, absolutely. Text processing and editing are central to pretty much everything. You'll need to get comfortable with editors like Vim or Nano. Now, Nano is more straightforward for quick edits, sure.
Easier to start with.
Definitely. But mastering Vim with its modal editing, that opens up a whole world of efficiency for serious admin work. For just viewing files, you've got cat for quick dumps to the screen, less and more for paging through bigger files. Less is generally better, lets you scroll back and forth.
Tail-F is indispensable for logs, right? Watching them in real time.
Exactly. Tail-F is critical. And head is useful too, seeing the start of config files. But for pulling out specific information, grep is your friend, and egrep for extended patterns. And here's where the real magic happens. Redirection, using the pipe to send output from one command to another.
Chaining commands together.
Precisely. Redirects output to a file, overwriting it, appends to a file. 2 redirects error messages specifically.
Right.
T is neat, sends output to both a file and the screen. And zargs builds commands from standard input. Combining these, that's how you build complex solutions from simple tools.
Like that TS grep and Jenks example you mentioned. Find the process, but it's really about troubleshooting.
Exactly. That kind of chaining is fundamental. Lots of RHCSA questions test exactly that ability to combine simple tools.
Okay, building on that. Once you can manage files, you need to manage who is doing what. Switching users, getting admin rights.
Yeah, that brings us neatly to system access and user switching. You absolutely have to master su and sudo. Su lets you switch your user identity, often to become root. Sudo lets you run just a single command with elevated privileges.
And configuring sudo itself is important.
Critically important. Using vsudo to edit the configuration file safely is a core security skill they test. Then there are the basics. WAMI to check who you are now. WAMI shows your user and group IDs, just history. A huge time saver, lets you recall previous commands.
Definitely use that one a lot.
Exit closes your shell. CD changes directories. PWD tells you where you are. These are your kind of everyday navigation tools.
And what about bundling files up, say for backups or sending them somewhere?
Right. Archiving and compression, key for efficient management. You'll learn tar. It bundles multiple files into one archive. Remember the common flags, -e, create, -x, extract, -u verbose, -f for the file name.
Often see those combined, like tar-xcff or tar-xf.
Exactly. They add gzip compression. JJ would add bzip2 compression. Which brings us to the compression tools themselves. gzip, gunzip, bzip2, bunzip2, and next speed gzip is fast. bzip2 often compresses better. Gzip gives the best compression, but it's slower.
So you choose based on whether you need speed or maximum space saving.
Pretty much, yeah. It depends on the context.
Okay, inevitably, you hit a wall. Forget a command flag. Where do you look for help right there on the system?
That's where the built-in system documentation is your lifeline. The man command is king here. It gives you detailed manual pages for almost everything. Flags, arguments, examples. It's like the system's own Wikipedia.
And learning to navigate the man pages themselves is a skill.
Absolutely. Using to search within a page, for example. It's essential not just for the exam, but daily work. Info sometimes gives more structured hyperlinked docs. And locate finds files fast, but remember it needs its database updated with updated GZ now and then. These tools mean you often don't need to leave the command line to find answers. Crucial for quick problem solving.
Okay, let's move to the next major landmark on our map, software management. This feels really core to keeping a system healthy, getting software on, updating it, taking it off.
It really is, and it brings up that critical admin question.
Yeah.
How do you make sure your system has the right tools, stays up to date for security, and, doesn't break in the process? For Red Hat systems, the main tool now is DNF, Dandified YUM.
Right. Used to be Yum.
It did. DNF is the modern replacement. You'll use its subcommands constantly. DNF install, DNF remove, DNF list to see packages, DNF search to find things, DNF update vital for security patching. DNF provides is useful too, finding which package owns a particular file, and DNF config manager for managing your software repositories, maybe adding third-party ones.
So DNF is the high-level tool, but Linux systems still have RPM, right? The RPM package manager itself. When would you use RPM directly?
That's a great question. Usually DNF is better because it handles dependencies, but you might use RPM directly for more granular control, or maybe if you're dealing with a single .rpm file someone sent you, perhaps offline installation. The options give you finer control. RPM-Q to QWERTY package info RPM-QI lists everything installed, very common. RPM-I to install a specific .rpm file, .rpm-E to erase or uninstall. RPM-V is interesting. It verifies a package against its original install checksums and permissions.
Yeah, checking for corruption or tampering.
Exactly. And RPM import for GPG keys to verify package signatures. That's a key security step.
Right.
So yeah, you might use RPM for debugging DNF problems or handling custom-built packages sometimes.
And what about containerized apps? That's getting bigger, isn't it?
It is, and that's where Flatpak comes in. It offers a sandboxed environment for apps, makes distribution simpler, potentially enhances security. You'll use commands like flatpak remote add to add repositories, flatpak install, flatpak uninstall, and flatpak list to see what you've got installed. It's a different model from traditional packages, but definitely something to be aware of.
Okay, shifting gears now. Storage.
Wow.
This is often where people get a bit intimidated, but it's so fundamental. Reliability, scalability.
Absolutely. Effective storage management is critical for pretty much any server. You can't avoid it. We need to sort of demystify partitioning disks first. Then we'll dive into the power and flexibility of logical volume management, LVM. For partitioning, you've got tools like fdisk, the classic one. JDisk is for GPT partition disks, which is standard now for larger drives. And parted is another powerful tool for managing partitions. Then, to check your work and tell the kernel about changes, you use liplt to list block devices.
That gives you that nice tree view, right?
Yeah, it's very clear. Bulkit helps identify devices by their UUIDs or labels, super useful for configuration files like etc. stab. And partprobe forces the kernel to reread the partition table without a reboot, which is often necessary after making changes.
Okay, partitions created. Now, LVM. You said it's powerful because of abstraction. Tell us more about those layers, PV, VG, LV. How do they work?
Right, LVM's power comes from abstracting the physical storage. It gives you amazing flexibility that old-style fixed partitions just can't match. Think about needing to grow a file system later. With LVM, you often can, without data loss or reformatting. It does this with layers. First, physical volumes, PVs. These are your raw partitions or whole disks that you dedicate to LVM. You use pvcreate to initialize them. pvdisplay shows their status, pvroof takes them out, pvscan looks for them.
So you mark the physical space for LVM.
Exactly. Then you pool these PVs into volume groups, VGs. Think of a VG as one big flexible pod of storage. You use vgcreate to make a VG, vgdisplay to see it, vgextend lets you add more PVs to grow the pool later, and vgremove, vgscan for management.
Got it. Physical bits into a pool.
And finally, from that VG pool, you carve out logical volumes, LVs. These LVs are what your operating system sees and uses like traditional partitions. You make them with LVcreate, view with LVdisplay, extend with LVextend, that's the magic for resizing online, and LVremove, LVscan. This This whole layered approach, PV into VG, LV out of VG,
Yeah.
that's what gives you the confidence to manage storage dynamically. Create, resize, adapt.
So once you have those LVs, those logical partitions, you still need to put a file system on them and make them usable, right?
Exactly right. That's file system creation and management. You'll use mkfs.xfs or mkfs.exe4 to create the actual file system structure on the LV. XFS is often the default on Red Hat systems now. It's very robust. You also need mkswap to format an LVs as swap space. To make them accessible, you use mount to attach the file system to a directory in your file tree, like data or home. Mount to caches it. Find Djere is handy for seeing what's currently mounted where.
Good for troubleshooting mount issues.
Definitely. Swap on and swap off, activate and deactivate swap space. And for monitoring usage, DF shows disk-free space per file system, while DUS shows disk usage for specific files or directories. Very different, both essential. And crucially, for resizing existing file systems after you've extended the underlying LV, you use XS gross for XFS or resize 2Fs for X44.
What about sharing files across the network, making storage available to other machines?
Yeah, that introduces network file systems. Typically, NFS is covered for RHCSA. You might use show mount to see what a server is exporting or what clients have mounted. You'll need to understand the concepts behind AUTOFs for automatically mounting network shares on demand. And know about the NFS utils package, which provides the necessary client and server tools. It enables that seamless file sharing across your network.
Okay, shifting slightly. One of the absolute most common headaches, especially for newcomers, must be file permission problems. Permission denied. How do you fix that?
Oh yeah, permissions are fundamental. Get them wrong. And things either don't work or you have a massive security hole. LS is your starting point. Seeing those RWX permissions, the owner, the group.
Reading that output is key.
Absolutely. Then chmod changes the permissions, the modes.
Yeah.
Chown changes the owner. Djere changes the group owner. But sometimes basic permissions aren't enough. That's where access control lists, ACLs, come in. Getfacl shows you the ACLs on a file, and setfacl lets you set much more granular permissions, like giving one specific user access without changing the group.
So more fine-grained control.
Exactly. Mastering these tools, chmod, chown, GHRP, and the ACL commands, is essential for both security and just making things work correctly.
All right, this brings us to operating the system day to day. Keeping it running, monitoring its health, automating tasks, the real pulse of a live server.
Definitely. These skills are vital for uptime and efficiency. Let's start with system state and boot process. You've got the basic shutdown, reboot, power off commands for controlled stops and starts. But the real power in modern Linux, especially Red Hat systems, is systemteltl. Using systemteltl isolate lets you switch between system targets, like going from graphical mode to multi-user command line. And systemteltl set default configures, which target the system boots into by default.
What about managing the actual programs and services running? Seeing what's eating CPU or memory?
That's process management. A daily task for any sysadmin PS gives you a snapshot of running processes. PS is a common way to see everything. Top gives you that dynamic, real-time view, constantly updating, showing CPU, memory usage. Learning to navigate top effectively is a huge help.
Yeah, understanding top's output is crucial.
It is. Then you have kill and kill to terminate processes that are misbehaving or stuck. And nicer and nice let you influence process scheduling priority. You can make critical tasks run faster or throttle down something that's consuming too many resources.
And when things go wrong, how do you figure out what went wrong? Looking under the hood? Logs seem key.
Logs are absolutely crucial for troubleshooting. JournalCitl is your main tool for querying the system journal. It collects logs from the kernel, system services, everything. And it has powerful filtering options by time, service, severity. dmeg specifically shows kernel ring buffer messages. Really valuable for diagnosing hardware problems or driver issues, especially during boot up.
So JournalTel for general system logs, dmegged for kernel-specific messages.
That's a good way to think about it, yeah. Both are indispensable for finding the root cause of problems.
You mentioned performance tuning briefly earlier.
Yeah, just a quick look at Tuned Atom. It lets you apply predefined performance profiles, things like throughput performance or latency performance. It tweaks various system settings automatically for certain workloads, saves you from having to manually adjust lots of kernel parameters.
And moving files between systems securely. That happens all the time.
All the time. Secure file transfers are essential. You'll learn CP, Secure Copy over SSH. Simple and effective for single files or directories. SFTP gives you an interactive secure file transfer session. Feels like old FTP, but it's encrypted via SSH and sync. Incredibly powerful and efficient for synchronizing files locally or remotely. It only transfers the differences, which can save massive amounts of time and bandwidth.
So different tools for slightly different secure transfer needs.
Exactly. They all rely on SSH underneath.
You mentioned system title for system state, but it seems like it does much more, especially with services, like the heart of the system.
It really is. Systemtitl is the command you use constantly to manage services in modern system-based Linux. You use systemtl start service name to start a service, systemtl stop to stop it, systemtl status. You'll run that dozens of times a day to check if something is running, if it failed, see recent log entries.
The go-to command for checking on things.
Absolutely. Systemtl enable makes a service start automatically at boot. Systemtl disable adopts that. Systemtl mask is stronger than disable. It prevents a service from being started at all, even if another service tries to start it as a dependency. And we mentioned set default for boot targets earlier. Mastering systemtl start, status, enable, disable. It's non-negotiable for RHCSA.
Okay, what about making the computer do repetitive tasks automatically? Daily backups, weekly cleanup scripts.
That's task scheduling. Automation is key. Crontab is the main tool here for managing scheduled commands that run periodically. Daily, weekly, hourly, specific times. Cron jobs are the backbone of server automation.
Setting up those cron schedules can be tricky sometimes.
It can take a bit to get the syntax right, yeah. For tasks that need to run just once at a specific future time, you use at. And at_q lists the jobs waiting in the at queue. At_trum removes them. Automating frees you up for more important things.
Accurate time is also surprisingly important, isn't it? For logs, security.
Crucial. For time configuration, you use timedetectl. It lets you query and set the system clock, the time zone, and manage time synchronization settings. Underneath, Chronicles lets you interact with the Cronid daemon, which handles the Network Time Protocol, NTP, synchronization on Red Hat systems. Keeps your clock accurate against reliable external time servers.
And finally, the very beginning, managing how the system boots up. The bootloader.
Right, bootloader management. On Red Hat, that's grub2. You need to understand grub2melk config. It generates the main grub configuration file. You'd run this after, say, editing the default grub settings, or maybe if you needed to reinstall grub. And grubby is a handy command line tool for modifying specific boot entries directly, or viewing the default kernel. Easier than editing the config file manually for simple changes.
Phew, okay. We've covered a lot of ground in operating the system. Now, the final stretch, networking and security. These feel like the skills that really define an enterprise-ready admin.
Absolutely. This is where you demonstrate that practical, hands-on ability to keep a system secure, reliable, and connected in a real-world setting. These are hireable skills. So managing basic networking. Configuration is key. You use nmsli, the Network Manager command line tool, and maybe mmtui, the text UI version. Both are pretty user-friendly for setting up connections, IP addresses, DNS, gateways.
Easier than editing config files manually.
Often, yes, especially for standard setups. But you still need to understand the underlying concepts. You also use the powerful IP command. It replaces older tools like ifconfig and route.com, or just ipba is probably the first thing you type to check network interfaces.
Use that constantly.
Yeah. And hostmectel manages the system's host name easily.
And protecting the system from network threats. The firewall.
Firewall management is crucial, primarily using firewall-cmd to interact with the firewall service. It uses it to manage zones, open or close specific ports, allow predefined services like SSH or HTTP, both for the current session and permanently so the rules stick after a reboot. Vital first line of defense.
And essential for any system with more than one user, managing who can log in and what they're allowed to do.
Precisely. User and group management. You'll use user add to create users, user mod to modify them, change shell, groups, etc. Userdel to remove them, password to set or change passwords. And change is important for managing password aging policies, forcing users to change passwords periodically.
Security best practice.
Definitely. For groups, it's group add, group mod, group del. Subtassword is used to administer group memberships, like adding users to groups. And we mentioned it before, but vsudo is the only safe way to edit the sudoers file to grant specific users or groups permission to run commands as root. Get that wrong editing manually, and you could lock yourself out.
Okay, the big one, the final layer of defense, often seen as complex but super powerful. Linux.
Ah, yes, Linux. Security-enhanced Linux. It is crucial for really locking down a server beyond just standard file permissions. It implements mandatory access control, MAC, meaning the kernel enforces security policy directly.
It has a reputation for being tricky.
It does. The learning curve can feel steep. But fundamentally, it's about contexts. Files have contexts, processes have contexts, and policies define how contexts can interact. You'll learn get enforce to see if it's enforcing, permissive, or disabled. Set enforce to switch modes temporarily, often setting it to permissive, is a first troubleshooting step. Sedatus gives you a full report. See the context. LC-G for files, PS-G for processes. That Z flag is key.
So you see the labels attached to everything.
Exactly. And if the labels are wrong, maybe after moving files, you use RestoreCon to fix them based on policy, or CheckCon to change a context manually, though RestoreCon is usually preferred. For managing the policy itself, Symanage is the tool for making persistent changes, like defining new file contexts. And GetSpool and SetSpool manage Linux Booleans. These are on-off switches for specific Linux behaviors, letting you fine-tune policy without rewriting it.
So it's about understanding the context labels and the Booleans.
That's a huge part of it. Understanding its deny by default nature and how to interpret audit logs when it blocks something are key skills.
What about default permissions? When a new file gets created, what permissions does it get automatically?
That's controlled by a mask. It sets the default denied permissions for new files and directories. It's a 4-digit octal number, but the last 3 digits are what matter. They're subtracted from the base permissions, 606 for files, 777 for directories.
So a mask of 022 means new files are 644 and directories 755.
Exactly. It's a small command, but foundational for baseline security.
And finally, secure remote access. Getting in without typing passwords all the time, which is more convenient and more secure.
Right, key-based authentication using SSH. It's the gold standard. You use Slish itself, the client. Slish-Cajun generates your public and private key pair. You protect your private key, and you distribute your public key. Slish-Copyaid is a super convenient script to install your public key onto a remote server's authorized keys file. Once that's set up, you can slish in without a password. It's dramatically more secure than passwords and way more efficient for scripting and daily admin work. Absolutely critical skill.
So after that journey through the treasure map, what does this all mean for you, the listener? We've covered a huge amount, from those everyday file commands and text tools through the complexities of LVM storage, right up to the critical layers of networking and Linux security.
Yeah, this deep dive, I hope, shows that mastering these commands isn't just about ticking boxes for an exam. It's really about getting that practical, hands-on know-how, the kind that lets you keep systems secure, reliable, running smoothly, whatever the environment. You should now have a much clearer picture of the whole landscape, not just the what, but the why and the how of these commands, their power, their context, even their potential pitfalls. And maybe this leaves you with an important question to think about as you go forward. Forget the exam for a moment. How does understanding these fundamental building blocks of Linux actually empower you? How can you use this knowledge to troubleshoot, to innovate, to solve everyday tech problems, maybe even ones completely outside a server room? Because this knowledge, it's a genuinely versatile superpower in our digital world.